Chapter 6, Constant Pressure Hydrating Hydrant Fuel System Type 3 Phyllis. Unified Facility Criteria Operation Maintenance of Petroleum System, USC 34603. Sorry, there we are. Constant pressure hydration. Constant pressure hydration fueling system type 3 Phyllis. 6.1 General information. The constant pressure hydrating fuel system is the newest system used by the Air Force. It was conceived by the Phillips Petroleum Company in mid-1950s for refueling military transportation bombers and has come to extend to use since the mid-1980s. The standard Type 3 system is designed for a maximum of 9,085 liters per minute or 24,000 gallons per minute. The earlier system was designed for larger than 22,712 liters per minute or 6,000 gallons per minute, but a larger pipe size, low normal flow surge problems may be these systems impractical. They may have some alterations to system design, but current standard of the Department of Defense standard design 7848 2428 88 AF pressurized hydration fuel system type 3 available for the download and hard copy at the Corps Engineering Huntsville Center at HNDUSA's.Army.mil. The system consequently under pressure when energized respondent automatically refueling defueling requirement supervision is not required at the pump house during the automatic mode of it pump run lit and emergency shut off switch as are provided with the RCC. Any number of the aircraft parked along with the fuel looping can receive fuel simultaneously up to the flow capacity of the system. Additionally, the aircraft can be fueled while the others are refueling because the system relies pneumatically operated valves at the hydrants. The electrical problems encountered with the Type 1 and Type 2 systems does not exist. The heart of the Type 3 system is a computer microprocessor pump house control room in which the controls of the component operation and product recovery tank is provided with the collected liquids for the pressure relief, strain drainers, filter separators, automatic drains when used, low point drains, operating storage tank, water draw off system. The Type 3 system has many components similar to those covered in preceding chapters under Type 1 and Type 2 systems. The system includes filtration, above ground operating storage, pump house control system, room, hydrant loop, and a hydrant servicing vehicle. Checking out the stands and system, sometimes fill stands. The pump house contains components include the API standard 610 pumps. The API has horizontal filter separators, issues and returns to Venturis's, both direct pressure, differential pressure transmitters, DPTs, and automatic control valves. The loop also includes the hydrant control valve each hydrant and HSV. Typically used between the hydrant outlet and the aircraft when the filtration is not required at the skin aircraft at the final graphic acceptable. 6.2. As piping. As the aircraft become more sophisticated, it is increasingly important to maintain fuel quality, especially thermal stability. Contact iron and steel degrades thermal stability. Therefore, the use of non-ferrous coated materials is emphasized for the piping from the seat of the filter separator to the issue field separator. Only carbon steels and stainless steels, aluminum, if not buried, may be used. The hydrant system using the stainless steel pipe downstream of the issue of the filter separator. The filter separator removes the fuel degradation products degraded with the coating particles before entering the loop. Stainless steel prevents the fuel deterioration, protects thermal stability. All underground metal piping must be protected by exterior coating, cathodic protection, and making pipeline repairs, taking care when replacing or repairing coatings, even though the most minuscule break in the coating can be starting point for corrosion. Be aware the buried stainless steel corrodes faster than carbon steel and must be treated carefully. Alright, 6.3, receiving storage. Receiving storage, typically the fuel is received at the base fuel storage and areas delivered to the Type 3 system pipeline. Figure 6.1. Fuel enters into the system through the 40 mesh strainer upstream to the receipt of the filter separator. The strainer is equipped with the piston type DP gauge and a bottom drain pipe to the product recovery tank. The maximum allowable DP across the strainer is 10 pounds per square inch differential. 10 pounds square inch differential, and the operator must open and clean the strainer once the fuel passes through the strainer. Moves to the receipt of the filter separator, bypasses the bypass valve BPV, the federal filter separator pipe with the parallel with a bypass valve and manifold together. The receipt of the filter separator with the API 1581 Group 2 Class B rated 600 gallons per minute. Each of the filter separator control valves will close and the bypass valve will open automatically when the separator separates the DP reaches the 15 pounds per square inch and differential. All after following through the receipt of the filter separator, the bypass valve, the fuel passes through the 12,000 gallon per minute meter, then through the HLSO valve into the operating storage tanks. Alright, 632 storage tanks. Figure 6.1 operating storage tanks have the cone roof, aluminum honeycomb floating pan, and 5% slope floor to center sump. These tanks are fully coated inside. Existing storage tanks may be used for the operating tanks when distance with the Type 3 fueling apron to the tanks is less than 1.6 kilometers. They are upgraded to the latest design standards for the operating storage tanks. New tanks must be constructed with a distance exceeding 1.6 kilometers to provide with the two tanks for each of the hydration fueling system. Operating tanks typically have a capacity of 25,000 barrels or 5,000 barrels or 10,000 barrels. Overseas operating tanks are typically cut and covered tanks, filled construction underground storage tanks. 6321 high level alarm HLA. High level alarm is installed on each of the tanks to show when the tank is full. Further filling of the should stop. It is the alarm just before the high level shut-off operator valve closes to the point stop of the flow in the tank. When actuated, the high-level alarm window pump and control panel with the pumping control panel PCP flashes and the vibrating alarm sounds. After the operator announces the alarm, the auto alarm stops. The visual warning becomes steady. Then, once the fuel level drops below the high-level alarm setting, the visual warning device deactivates. The high-level safety operating valve. Each operating storage tank is equipped with a high-level safety operating valve on the fuel inlet float assembly at the tank. The high-level shutoff point, figure 6.1.2. When the tank fuel reaches the float assembly located on the side of the tank, the float assembly directs fuel into the high-level safety operation valve control loop, and the high-level safety operation valve to close and stop the fuel flow of fuel in the tank. The high-level safety operation valve is equipped with a check feature to prevent reverse flow. The float assembly also has a manual tester so that the rotary disc assembles in the high-level safety operator valve closing feature can be checked without filling the tank of the fuel. With some high-level safety operator valves have the closing speed adjustment. Alright, this shows the constant pressure hydration fueling from the high-level HHL tanks 1 and 2 with jet fuel GP8 going into these are kind of like, these are valve diagrams. It shows the 610 tanks with the 4AF roofs and kind of like a Pritchard yard here. Can't tell you really much more. Alright, this is a high-level safety alarm valve, the check valve ejector, high troll to the remote control check valve, VPI, outlet and inlet, and flow clean strainer, which look like the 413AF5A valve that we looked at in the last couple chapters. 6323 high level alarm. The float assembly with the alarm above the high level safety operating valve with the float assembly below. The tank overflows the vent. The alarm indicates both the high level alarm and the high level safety operator have been ineffective. The tank and is about to overflow. The this actuates flashing of high level alarm. A window of the control point and resonating horn. After acknowledgement, the horn stops. The window stops flashing but stay lit until the levels drop between the high level and high level alarm. The low level alarm. Each operating storage tank is equipped with a low level float assembly at the bottom of the tank. The low level float alarm shut-off switch controller will cause the visual alarm to annunciator panel resonating alarm and shut down the fuel pumps when the fuel drops below the predetermined level. The high-level alarm test procedure manually tests whether the high-level alarm and the high-level alarm, isolating the float assembly from the tank, filing from the slowly with the fuel of the high-level alarm sounds with the vibrating horn and the high-level sounds with the resonating horn. Both alarms will activate visual alarm with the announcer panel. The automatic audio alarm should sound outside the building with both of the control system. After testing and draining the fuel from the float assembly, the drain valve before operating the tank and isolating the valve to prevent fuel from draining into the tank above the float pan. The low-level alarm test procedures. Testing for the low-level alarm, isolating the float assembly from the tank, draining it until resonating horn or visual alarms are activated with the announcer panels outside the building. After testing and closing the drain line, reopening the tank isolation valves. Alright, 6327 automatic tank gauges. All tanks handling jet fuel will have automatic tank gauges installed. This system is used to transfer inventory control of the Petroleum Ram Division of the Air Force Petroleum Officer AFPET, Fort Belvoir, Virginia. The Department of Defense agent is acquiring these systems because the unique software that needed the interface of the DoD fuels accounting system are fast. Alternate, the system must not be installed. Outlet valves. Each tank of the manual double back and bleed valve with the tank outlet. The Type 3 system and an outlet valve must open and close for the system to operate. The tanks are equipped with a limit switch and illuminates the light on the switch. System details of the displays is shown as follows. Shows if the valve is open or closed. The microprocessor also uses single define which tank should be monitored from low-level conditions. The outline lines with the tank feed with the pump suction manifold pumps. Alright, 6.4 pump house. The paragraph covers the pump house components. We will trace the flow of the fuel through the system during the refueling operation. Fuel pumps, refueling pumps at 600 gallons per minute. Single stain central figure, horizontal mounted vertical radial split case and its impeller and with the end suction top vertical discharge and conforming to API standard 610. They're statistically dynamically balanced for all flow rates from no flow to 120% design rate. 642 flow switches. Typically, an open flow switch is installed downstream of each of the pump discharge. When there is flow, a vane pipe is raised and rotating attached and shaft closing, double pull, double throw, snap action switch, allowing the pump to continue running if the flow is not established within the preset time. The microprocessor calls the unrepresentative pump. Calls off the unrepresentative pump and calls on the next pump in start sequence. 643 rate of flow and non-surgeon check valve for a 41A AF at 1A. 6431. This valve is very similar to a non-surge check with the valve using Type 1, Type 2 systems, except it is provided with a flow control using orifice plate and the DP controller. The flow control is typically set for the 650 gallons per minute to keep the pump from operating outside pump curve when the open pump discharges the multiple filter separator. Alright, figure 6.3 is the rate of flow and non-surgency check valve 41 AF1A. Shows the check valve ejector and the CV flow control with the VPI check valve and the CDSH for the inlet orifice into the outlet flow cleaner strainer. Valve setting of the CDSH to be the rate of the flow control, turning the adjusting stem to the clockwise to increase the flow of the fuel, of the counterclockwise to decrease the valve should be set at 650 gallons per minute. The following valve operating in the set, adjusting the control valve flow control, turning the control valve, adjusting the stems closing to make the main valve slower, the counterclockwise to make the valve open faster. Set the valve to it slowly so the pressure surge does not damage the filter separator and downstream equipment. The main valve should open in about 20 seconds. The filter separator provided with both the receipt and issue Type 3 system storage tanks. The issue the filter separator modified together with the discharge line for the issues of the pump. The filter separators are rated with the 600 gallons per minute. See Chapter 3 for detailed description. The field separator control valve. Only difference between the 41AF 2SC figure 6.4 and 40AFC figure 2C figure 5.3 is used only in Type 2 systems, and the 41AFC 2C has check valves installed to prevent the reverse flow. The valve still controls the rate of fuel flow and closes when the excess water is detected with the filter separator. Most bases have deactivated the water shutoff feature. Figure 6.4 filter separator control valve 41AFC 2C. Shows the remote control pressure going into parallel lines with the three-way hydrocom check valve control, and also three lines going through the inlet or the inlet orifice plate, the VPI and the check valve. The VPI runs on its own from the three-way hydro leader, and the check valve from the outlet to the CDS at TBH remote control pressure. 6452 valve settings. While the one opening, the running, the fuel flowing through the one separator, turn the CDSH2, adjusting stem clockwise to increase the fuel flow through the valve, counterclockwise to decrease it. Use the DPT to adjust the flow of the about 600 gallons per minute. Alright, 646 emergency shutoff valve, ESO valve 136AF9B. The emergency shutoff valve with the figure 65 has two solenoids energized and powers on a table, enabling the main valve to open the fuel flow. Show the power fill and emergency stop button push, and solenoids will be de-energized. The main valve will close in 10 seconds. And the valve also has a terminal relief valve feature that relieves excessive cover the chamber pressure back to the valve inlet. Later, the differential relief is used to maintain a relatively constant DP between the inlet and outlet main valve. The emergency shutoff valve features performed alternate means for design completed since 1999-1. This shows another circuit from the inlet to the outlet on the outside, then following the next closest inlet to the ball check valve, and back to the same looping, and a solenoid going through the flow cleaner with the hydro-cooler tri-controller to the black bell chuv solenoid B three-way com net north and differential control. 6462 valve setting. The turning of the adjusting stem of the CDB 7 clockwise to increase the DB, counterclockwise to decrease the DB should be about 10 psi. 647 issue venture the 254 millimeter issue the venture and downstream of the emergency shutoff valve is typically related to the 24,000 gallons per minute. It's similar to the orifice plate in operation, but it's much more accurate. It has about 12.7 millimeter connection for the piping of the DPTS using the DPTI microprocessor measuring issue flow for the return flow. The venture control starting stopping with substantial pumps. 648 pressure identification transmitter. The two pressure identification transmitters are connected directly to the main issue line just downstream of the emergency shutoff valve. The pressure indicating transmitter reads the system pressures between 0 and 250 psi. The microprocessor is programmed to call the lead pump when the system pressure drops below 60 psi. Call it off, and when the system pressure reaches preset between 135 and 175 psi, the micro uses the 4 and 20 milliampere signals of the transportation transmitter turn the lead of the pump on or off. The signal directly proportional to pressure being measured, calibrated with the pressure identification transmitter with the manometer digitally type of the recommended for the manufacturer and structure of the detail. The DPT measures the DP carry across the venture that displays expressly flow in the gas per minute, gallons flows in gallons per minute. There are two DPTs connected with the issued venture with the range of the 0 to 24,000 gallons per minute. The 4 connected return ventures, 2 of the 4 for the low for the row range of the 0 to 100 gallons per minute. The remaining the 2 are high flows with a range of 0 to 800 gallons per minute. The microprocessor uses 4 to 20 amperes. Similar with the 6 transmitters turn subsequential pumps on and off. The signal is directly proportional to DP being measured, calibrating with DPT's manometer digital type, recommended with the firm manufacturer's instruction. 6410, the hydrant loop. After leaving the issue of the venture, the fuel flows from the hydrant loop back to the operating storage tank. The loop is under the parking apron with the hydrant control point, and at each of the fuel point automatically idle mode. But the loop is under the constant pressure of 75 psi, protected with the thermal expansion, relieving the excessive pressure of the operating storage tank. At the drop system pressure of 60 psi causes the lead pump to be energized because the hydrant loop is very long, and high point vents and low point drains are provided throughout the number of locations of the hydrant outlet or based on the type of the aircraft mission. Following fueling requirements, the hydrant pit is molded in fiberglass and counterblazed with aluminum cover. It opens at 90 degree, requires 133.4 newtons or 30 pounds of force to open it, and 222 newtons or 50 pounds of force to enclose it. That most of the new covers are designed to watertight. Pipe penetration is in the pit are sealed by the Buno end boots clamped on the pipe. The hydrant riser is 101 millimeters or 600 gallon per minute, flows through the 152 or 1200 gallons per minute through a 452.5 milliliter minute. Any appropriate size ball valve installed with a hydrant control valve. 6411 hydro control valve. The hydrant control valve provides the constant pressure that relieves the excessive pressure air and sensing and license line connected with the hydrant safety valve and the hydrant control valve three-way hydrol. The hydro safety valve pneumatically detonated to depress and air supplied with the three-way hydrol, allowing the valve to open the fuel sensing line and connected with the hydro safety venture and the pressure to reducing the control of the CR and CRL 36.2 AF8 and venture is calibrated to provide the same pressure as the actual nozzle prepares the skin of the aircraft. The CRA maintains 45 psi in the nozzle. The hydro control valve is designed to close rapidly with the nozzle pressure exceeding the 50 psi setting of the CRL to reopen the pressure drops below the set point. Alright, your HCV valve, basically the same kind of red, but it has a 2-air dead man control. Valve setting typical CRA as 45 psi or is 50 psi. So if your CRA is 45 psi, CRL is 50 psi. The control turning with the adjusting stem with the crew clockwise increase of the pressure counterclockwise decrease, and after establishing fuel flow with the hydrant safety valve with the refueling truck through the CRL and 36.2 AF and adjusting the CRA to 50 psi, turning the CRL adjusting counterclockwise until the valve begins to close. Next turn the CRL counterclockwise until the nozzle pressure drops to 40 psi. Main valve operating speed is adjusted. Turn the CV valve control valve. Control adjusting stem clockwise to make the valve open, or slower and clockwise to make the valve open safer. Most of the valves are set in 20 seconds. However, the dampen the nozzle pressure valve where the opening speed is needed to be retarded. Noted that the HCV is also located at the HSV checkout stand. Hydro safety valve, the Brooks valve with the hydro safety valve series is secondary with the CRL if the nozzle pressure reaches 50 psi. The air pressure of the hydro safety valve, hydrant safety valve dictates that at the point of the Brooks valve, the air pressure on it must be set with a 10 psi above the pressure relief setting required with the Brooks valve. Setting the air pressure 65 psi will close the Brooks valve to 55 psi. Hydrant control valve will close 5 seconds if pneumatical hose ruptures and bleeds air from the system. And never for the new hydrant safety valve, the pressure of the setting procedure may be different. Refer to the manufacturer instruction. The hydrant central valve control valve is equipped with the API adapter 36.4 AF2 6413 return venture. The 141 millimeter venture is upstream of the back pressure control. The back pressure control valve, the BPCV, is similar to issue the venture base, but is raised on 328 liters per minute. Is 800 gallons per minute. The back pressure control valve is set for 100 psi, measured in inlet furthest hydrant outlet, and modulates and maintain a loop pressure at a set point. The valve, the pressure reserved for the flow, 152 millimeters, will have solid and energize. The leading pump is called the de-energizing while the system starts the shutdown sequence. What is the solenoid energized with the enabled, meaning of the valve opens and closes. The CRL dictates when it is de-energized with the valve closes. This shows the back pressure control valve. Alright, it has an inlet and an outlet with the flow cleaner strainer. On the outside, you'll see the inlet goes out through the outlet, but it goes through a CRL, and the next lines go from the inlet to the 3-port solenoid into either to the C valve, control valve, the hydro CRL check valve, or the check valve has an easy main top to check valve outlet, and the CV control valve on the other side of the VPI, with the hydro and 3-port solenoid. You gotta watch the diagram path. Valve setting: place the person furthest hydrant outlet of the means communication with the person at the back with the back pressure control valve. Place the person furthest hydrant outlet in the means of the communication with the system person in the back pressure control valve to establish 100 psi for their hydrant outlet. Turn the back pressure control valve to CRD of adjusting the stem clockwise, increase the pressure, and counterclockwise, decreasing the pressure. Um, 61415 D-fuel flush valve with the D-fuel flush valve 58AF91. The valve with the figure 6-8 is controlled by the two different solenoids. Solenoid A controls the D-fuel portion of the main valve, holds the valve with the closed at any time the fuel pumping is running. Solenoid B controls the flush portion, but the main valve functions only when the system is placed in the flush mode. When the lead pump at the de-energized solenoid A energizes, allowing the valve to open, dropping the system pressure to 80 psi. When the system is idling in position, the valve will open to allow the defueling with the hydrant loop pressure to rise above 80 psi. Defueling is conducted by using the hydro safety valve with the pump the fuel and fuel off the plane force of the fuel in the hydrant loop at the rate of 300 gallons per minute at 165 psi. 165 psi overcome 80 psi setting of the 58 AFI 91 defuel flush valve and the valve openings. The solenoid B or energizes only when the system is placed in the flush mode. When the season for the system flushing is moved to the fuel through the pipeline as fast as possible, cleaning the loop. When the system is flush mode, energizing all the available fuel pumps, placing the pump hand off the auto switch and the hand position to get the maximum per minute foot per second. The flow hydrant loop. The 58AF91 defuel flush valve opens, allowing maximum amount of the fuel flow through the system. This shows the defuel flow valve 58A591. Basically, it's still a valve, but you got your CVs controls, your check valve, and same CRL, but with the solenoid A and B and a restriction check assembly. Valve setting: close the manual upstream with the 58AF pressure control valve, the pressure control valve, to ensure the system drops and does not foul with the valve while adjusting the defueling flush valve. When the CRL and the defuel flush valve, place the system on automatic mode, pressure the system. When the system shuts down, the CRL adjusting the system defuel flush valve counterclockwise until the age reaches 80 psi, repressuring the system, checking the system. When complete, reopen the manual valve upstream of the pressure control valve. 6416, the pressure control valve, the 50-80 millimeter valve reduces system pressure down to the 75 psi down during the system shutdowning the process to provide the thermal relief during the idle periods. The valve has the solenoid that energizes to close the valve with the pumping ring, running deorganize the lead pump to de-energize the de-energizing valve to reduce the system pressure to 75 psi. The thermal relief function is operable if the pressure risk above the 75 psi valve opens. The excessively pressure flows to the immediately operating storage tank. These valve opening close speed controls are typically at the 3 seconds. In some cases, to prevent valve shattering, the pressure control valve pressure sensing line is connected to a large defuel flush line. This is a pressure control valve, same thing, but you got your inlet, your outlet, your main valve, ball valve with a check valve control with a VIP for the checking, restriction, CV control closing, opening and closing, high troll, solenoid, and the CRL check and another check valve, running from the main head to the outlet. 6416 pressure system, the bottom of the pressure control valve with the 58 AF CRL. Place the system automatic mode in the pressure system. When the system shuts down, turn the CRL, adjusting some of the pressure control valve clockwise until the gauge reaches 75 psi. repressurize the system, checking the system. The hydro safety valve, checking out the sand, check out the outstanding of the 362 AF the hydrant control valve with the 364 AF2. Our American Petroleum Institute adapter, 463 filaments, 2.5 single point receptacles, and emergency stop with the switch of the hydrant control valve with this pipe with the hydrant loop with the downstream issue. Ensure the hydrant safety valve. Check out the stands and perform daily checks of the hydrant safety valve before using service aircraft. 6.5 product recovery system. The 6.5 tank design. The product recovery tank is 4,000 gallons. The double-walled steel tank with the interstitial leak monitoring. The annular space provided between the primary and secondary tank walls allowed the free flow of the containment and all leak product of the tank and the leak of the detection system attached with the installer monitoring of the either vacuum maintenance, positive air, pressure mount maintenance, hydraulic state, static pressure maintenance, probe detection monitor is continuously indicated with the pump control room. The controls console generates the visual audible alarm, and if it is leaked detected, the audible alarm has the remote alarm and initiator that can be head around the system. 6.5.2, the fuel transfer pump. The product recovered the tank of the deep well turbine while the capacity of 189 or 50 gallons per minute will driven with 180 revolutions per minute can automatically manually operated. In automatic mode, the float switch assembly operates the pump. The switch is either magnetically latching reading or the mercury actuated switch with operates on 120 volt 60 hertz AC power. The tank is 70% full. Switch assembly automatically energizing the pump. Fuels is routed through the receiving separators for the operating storage tank. Once the fuel level is pumped with 20% fuel, the pump shuts off and the pump fails to start and the tank reaches 80% full. The switch assembly alarms sounds an alarm. The overfill valve will mechanically activated within closing at 80%. This tank also has a hand-operated pump in removing water. So 6.5.3 product report recovering pipe system. The entire product recovery system consists 19 to 50 millimeters or 0.7 to 2 inch piping routed throughout the 2-3 system. The piping connects the pressure relief water draw off, some low and high point drains, fills separated water drains to protect the recovery tank line that is equipped in the hydraulic operating valve. Product tank recovery operating valve. The operating valve is diagrammed with the operating angle valve located on the foul line of the product recovery tank at the 6.410, but the valve closes at any time of the liquid level in the tank of the reach of the 80% with the used the float assembly similar to the float assembly used on all below ground storage tanks. The float also has a manual test lever designed to test the operation of the 2129A valve. The 2129AF valve is opening. A limited switch illuminates the green light on the pressure control pipe graphic display. A red illuminates the vibration horn will sound of the valve with the enclosure of the valve uses the pressure reserve tank connected to the discharge of the product recovery fuel tank transfer pump. The fuel transfer pump supplies pressure to the pressure reservoir and the check valve that should be hold of the pressure in the reservoir. Supply line of the pressure reserves is connected with the rotary disc assembly in the float. While the tank is less than 80% full, the float is the bottom position and aligning with the commonly supplied with all the port and two common drains with the port 1. In this position, the pressure maintained with the pressure reservoir is applied to the 2129AF sensor chamber. Since the cover chamber of the main valve is vented with the common drain of the float assembly, the pressure is sensing the chamber over the tank overcomes the spring tension on the top of the diaphragm holding the valve in the fully open position. While the tank is 80% full, the float rises aligned with the common valve, the port common supply, and with the port since the sensing chamber is not vented. Now vented, the pressure reserve is applied with the main valve cover the chamber. The main valve closes. All right, this is a diagram of an operating valve. Like anyone, you got the power control main valve, a check valve above that with a VPI, a discharge pump slop tank, pot head with the which is some kind of valve, but I guess it's the electrical line going into the the explosion-proof valves and manual tester for the float control, while the ball valve and the strainer and the orifices also are also on a circuit that goes from the discharge slop tank for the 8 check valve to the check valve, another check valve before it meets the pressure reserve, and the check valve goes, and from the pressure reserve for that check valve goes into one of the explosion-proof valves that was set. Basically, I guess 6.5 thermal relief because of the 229 AF would be held shut when the tank is 80% full. There is a means of relieving the excessive pressure on the product recovering piping system. This is done by CRL piping inlet and outlet of the 229 AF main valve body. With the product recovering pipe, the system pressure reaches 200 psi. The pressure relief control opens and it allows the excessive pressure to bleed around the overvalve. Fill valve. Pump control room. Pump control room contains the pressure control piping, the monitoring of the control center. The PCP is the heart of the Type 3 system. It contains the 2 microprocessors, a graphical display initiator panel, the alarms, pressure flows, and full records of the operating controls. 6571, the graphic display. The graphic display shows the layout of the system and the line drawing of the format. Green line shows the receiving hydrant loop with the return lines, and the yellow line showing the pump of the suction and the storage tank of the discharge line of the pump inlet. Yellow lines also show the water draw-off lines from the filled separated pressure relief valves, which go into the product recovery tank. Blue lines are in the pump discharge of the hydrant loop, including the back pressure control valve, the pressure control valve, and the defueling flow valve. Flush valve. The green-red light shows the valve opening and closed with its pumps and operating. A digital readout shows the fuel level in each of the tank and the tenth of each of the inch of the fuel is being received. Digital counter showing the amount of fuel received. 65272, an announcer alarm. The solid state alarm annunciator panel is ended the pressure control point. And 2, that contains a small windows that 25 millimeters, 38 or 1 1/2 inch of the range with the rows and columns of alarm points engraved on them. The typical example is the low level alarm, the high level alarm, and the high level alarm. A pump failure, microprocessor system faults. In addition, with the windows illuminating with the flashing, there are 2 different audible horns to alert the personnel in the emergency. One is vibrating horn, the other is a resonating horn. Should the alarm conducting occur with the visual indicator flashing the horn sound, the conditions must be acknowledged with the pressing of the acknowledgement button. The cause of the alarm to stop the flashing indicator. To show the steady light, the indicator will stay lit until the alarm condition is rectified. Should another alarm occur, the process would be the same. 65721, vibrating horn. The following conditions will cause the vibrating horn to sound. System failure is indicated upon detection of system alert. Pump 1, 2, and 3 failure. Pump 4, system 1 and 2 fault. Product recovery tank of the operating valve closed. Product recovery tank leak. High level product recovery tank. High level oil water separator. High level operating tank 1 and 2. High level ZP receiving filter separator. Engine generator fault. Resonating horn, all alarms. The following conditions will cause the resonating horn to sound. Emergency stop, low level operating tank 1 if the outlet is not fully closed. On low level operating tank number 2 if the outlet is not fully closed. High level operating tank 1 and 2. The pressure flow records mounted on the pressure control point is the 3-channel, the continuous plotting with the 2 speeds recorded with the issue. The 3 pens, different colors to record the system activity. 1 pen records the system pressure of 0 to 300 psi. Another is for the issue flow rates of 0 to 2,400 gallons per minute. At the last one, records the return flows rates of 0 to 800 gallons per minute. The stripe moves at either 25 millimeters 1 inch per hour. For the routine operation of 203 millimeters 8 inch per hour is more detailed information required for the system troubleshooting. 6574 operator controls are mounted with the pressure control point door panel. There's 3 position selector switches that allow either the automatic off or flush mode operation. The second selector switch allows the selection of the lead pump, and it has many choices as their pump. Selecting the lead pump also selects the sequence of pump operation. Selecting one as the lead of pump number 2 and 3 and 4 will follow in sequence. By selecting select number 2 as the lead pump, 3, 4, and 1 will follow in sequence. Other the control included with the emergency stop button and the test and reset the acknowledgement buttons of the annunciator panel. 6575 microprocessor. The microprocessor is the brain that actually turns the things on and off by reading the pressure and flows and the status relating to these signals to be installed in the program that translates the signals into action. These 2 microprocessors in the printer control point. They receive the power and separate with the identical power conditions in a battery system. They operate redundantly and cycle off and on without interruption. Only with microprocessor actively controls the system at the time, but the backup is continuously updated within the system data. This should activate the microprocessor fail with the system automatically shut off the backup and without the affecting a system operation control can be also shifted manually with the lockout key system. The operating program is stored in a battery back memory and fully capable of the cold starts without operator POL personnel intervention. Program cold starts values are permanently installed with the memory but are adjustable by using 2 thumb wheel switches, 2 push buttons, and a 20 chair charter alphanumeric display. Small changes can be made. Various types of microprocessors are installed in the field. Refer to the manufacturer's manual for specific details. 66 sequence of operation system. Of the automatic mode, the Type 3 system is intended to stay continuously pressurized at 75 psi, while the automatic idle mode is between 100 and 130 psi during the refueling operations. 6611 idle condition. The system is idle condition when the system is automatic mode and the non-system pumps are running periodically, while the automatic mode and idle condition with the system pressure may drop below 60 psi, even though there are no aircraft refueling is being conducted when the pit or pit 2, depending on the microprocessor selection, since the system pressure is below 60 psi, the control system will cause the following to start. The lead fueling pump will start. The bypass control valve solenoid will energize to enable the valve with the modular opening as its set point, typical between 100 and 130 psi. Further, hydrant outlet, the personnel control valve with the 58 AF3 solenoids will energize the close and the valve at any time the pump is running. The defuel flush pump valve solenoid defueling will de-energize the close. DC, the valve with the solenoid B to the flush the DC. This should energize the close anytime the system is not flush mode. The lead fueling pump immediately establishes a flow of 600 gallons per minute descents by the issuing of the Venture DPT. When the fuel is being delivered to an aircraft, the fuel will flow back to the immediate operating storage tanks through the return ventilator with one open running. When the return ventilator DPT senses the flow of the 560 gallons per minute and greater for more than 60 consecutive seconds for the microprocessor initiates the shutdown. During the shutdown, the solenoid of the bypass control valve and the de-energize to close. The valve causes the hydrant loop to pressurize to rise. When the loop reaches a 175 psi, the 3 things that happen. A microprocessor calls the lead pump off the lead pump, the solenoid A, the fuel and flush valve with the energizing enable the valve to bleed system pressure 80 psi personal control valve solenoid with the disabling energizing the valve to bleed the pressure of 75 psi. Now the system is back to the automatic model in idle condition. 6612 refuel conditions beginning the aircraft refueling operation. The operation must use the fueling equipment such as the hydro safety valve of the R12 hydrant hose truck, HHT hose cart, and phonographic to connect the hydro control valve with the API adapter to the aircraft. The control valve can be either hydraulically fueled, pneumatically air operated, depending on the type of the fuel equipment on the dead man system. That whenever the operator squeezes the dead man, the hydrant control valve begins to open. The system pressure at pit 1 and pit 2, depending on the microprocessor selection, drops below 60 psi with the control system, which follows the following. The lead fuel pumping will start. The bypassing control valve with the solenoid will enable the valve to modulate opening at its set point typically between 100 and 103 psi, and furthest hydrant outlet Phyllis. The patrol control valve with the 58 AF, the solenoid with the energizing control the valve anytime the pump is running. From the defueling flush valve, solenoid A will de-energize control of the valve, solenoid B flush, and the de-energizing control anytime the system is not in a flush mode. The lead fueling pump immediately establishes the flow of 600 gallons per minute sensed by issuing the venture of the DPT. The issuing of the venture of the DPT senses the 600 gallons per minute lead the pump running of the venture of the DPT senses the flow of between 150 and 210 liters per minute, or 40 to 50 560 gallons per minute. The lead pump continues to operate. No other pumps will start. And if refueling continues, an additional aircraft beginning with the fuel and the flow through the return venture can drop below 151 per minute, so 40 gallons per minute. With the only leading pump running with 600 gallons per minute. If the return of the venture of the DPT senses less than 151 per minute, 40 gallons per minute for the 10 consecutive seconds, the second pump will be energized, which two pumps of the 112 gallon per minute. If the return venture of the DPT senses less than 40 gallons per minute for the 10 consecutive seconds, the microprocessor will call on the third prime. With the 30 pumps of 1,800 gallons per minute, if the return venture to the DPT departure part senses less than 151 liters per minute, 40 gallons per minute for the 10 consecutive seconds, for the microprocessor will call on the fourth pump. With 2 at 3, 4 pumps running of the venture DPT senses between 150 and 40 to 700 gallons per minute, the activated pumps will continue to run without calling of an additional pump. With the lead, second, third, fourth pumps running in the venture DPT over the 700 gallons per minute, the 15 consecutive seconds, the microprocessor will call off the pumps in 2 to 3, 4 in reverse order after the 15-second interval. With only the lead pumping the 600 gallons per minute, the return of the venture of the DPT senses over the 560 gallons per minute and 60 consecutive seconds, the system will initiate the shutdown. During the shutdown, the solenoid, the bypass control valve, will de-energize control of the valve and cause the hydrant loop to pressurize the rise. When the loop pressurizes the reaches 175 psi, or these three things happen: the microprocessor calls off the lead pump, solenoid A, the defueling flush valve, with either the energizing valve with the bleed of the system pressure to the 80 psi. Pressure control valve solenoid within the de-energize the valve with the bleed pressure to 75 psi. Waiting B. No, the system is back to automatic mode and idle connection. Defueling conditions begin with the aircraft defueling operation. Operative connection with the hydro safety valve between the aircraft hydro controller valve. American Petroleum Institute adapted the hydro safety valve has an on-board dual fuel pump capable of pumping 300 gallons per minute or 165 psi. When the operating starts the defueling pump, the following sequence will occur if the pumps are running with the patrol control pressure control valve, the defueling flush valve, and the energizing control. The fuel beginning with the move of the aircraft will either go into any other aircraft connected with the system of the fuel will modulate with a bypass control valve opening between 100 and 130 psi to return refuel to the operating tank. If pumps and returning the person control valve, defueling flow valve, the de-energizing the fuel being removed from the aircraft will modulate open the pressure control valve with the 75 psi, the defueling flush valve with the 80 psi to allow for the fuel to operating in the tank, and no refueling operations are planned. The system can be placed in the flush mode to expedite the defueling. Note that the ensuring refueling pumps are not started when system is placed in flush mode. 662, the flush mode. Although the fuel entering the hydrant system is filtered, at least the contamination and water still enter the hydrant loop. Some contain the dropout in the system and intended to accumulate in low points to keep the pipeline clean. Fuel must flow in the minimum velocity of 1.865 feet per second. Calculation should show that a 0.312 inch line following the 227 liters per minute, 600 gallons per minute, will have the velocity of 0.5, 1.7 feet per second. 24,000 gallons per minute. The velocity of 2 meters per second is just over the minimum velocity of 1.8 meters per second. The complete flush system, at least twice the loop of the capacity must be pumped through the loop. Maximum velocity for the example. For the example, if Type 3 loop can be holding 20,000 gallons of fuel, the 40,000 gallon must be pumped through the system. If largest part of the loop of the 3.3 millimeter diameter pipe with the flowing through rate of 9,084 liters per minute or 24,000 gallons per minute, the system would be flushed through the 17 minutes of a total of 440,800 gallons, which is double the capacity of the loop. 662 flush procedures. Place manual valve at the required position to direct the fuel flow through the desired flow path through the receiving separator through the separator manual bypass valve. The pressure control point mode selector switching flush mode and following will occur. The bypass control valve solenoid will de-energize the control over the main valve. The defuel flush valve, the solenoid B will in exchange for the off of the valve will flow and establish. 62213 manually turn on the desired pump, replacing both of the MCC pump house hand off the auto power selector switches to the hand position when the pumps are started with the pressure control valve of the energizing control of the valve. Flush unit required to the amount of the fuel is moved with the system at the rate of at least 1.8 meters 6 feet per second. When complete, manual turn off all pumps, return all manually operated valves to the typical open and closed position, return all pump selectors, switch back to the auto position, place the mode selector switch in automatic mode in from the flush mode. Observe system operation to ensure the system returns to pressurized idle conditions. Emergency operation micropressor down. If the micropressors are down, the system can be started with the emergency fueling using the following procedure. Place fuel selector in the off position. Ensure the selected operating tank inlet outlet valves are open and closed with the manual valve in the inlet, the pressure control valve, the manual energizing bypass, the bypass control valve, solenoid to enable the valve to modulate it at the set point manually, starting with the fuel pumps that's required to place the MCC pump selector switch in the hand position. Operator must read the mechanical DPT located with the return ventral. If the DPT shows less than 151 liters per minute to 40 gallons per minute, with returning the operating tank manual start an additional fueling pump. If the DPT shows more than 269 40 limited per minute 600 gallons per minute, the manually stop and the fuel point of the manual stop operating last fueling pump. The emergency operation is complete. Open the manual valve before the personal control valve. Manually de-energize the bypass control valve. Solenoid return the fuel pump selector switch to the original position. During the fuel operation, the operator must continuously verify the operating tank fuel level to ensure the tank does not drop below the tank and low level. To verify the checking the level gauge of the tank. 664 night shutdown. In some locations, the common practice to shut down the system in the night. This may cause the system pressurized to drop in the vacuum range, especially during hot weather to warm weather. Warm fuel cools in underground piping, and air can get in the stand system in the through hydrant pipe of the valves. Hydro safety check out the stands of the valve to prevent leaving of the system on or using an airtight cover to the valve of the leaks. 6-7 leak detection. A rapid method of checking for the leaks in the hydrant system is leave the system in an automatic idle mode and count the number of times it must be repressurized a given period of time. Experience will tell how many times it is too many and so much a problem can indicate an internal leak through a systematic automatic manual valve with pressure relief area and eliminator and drain line, or external leak through the system piping and components.